giving us the equation, and we have to find all the asymptotes. They're telling us where all the asymptotes are, and then we have to find the equation. Okay? So if we look in part A, it says, write a possible rational function that has an asymptote at x equals 3 and y equals 0 and has an x-intercept at 2. So first of all, what kind of asymptote is x equals negative 3? Vertical, horizontal, oblique? Vertical, because x equals a number is going to be some sort of vertical line. So where did this come from in the function? If it's a vertical asymptote, did they get it from information in the numerator or the denominator of the function? Where do you pick out your vertical asymptotes from? The denominator set equal to 0. So basically, by them saying there's an asymptote at x equals negative 3, we know that in some function, they said rational function, so we go like this, that when you set the denominator equal to 0, you get x equals negative 3. So what must be in the denominator? Good. Okay, so x plus 3. All right, and then it also says, and y equals 0. Y equals 0 is what kind of asymptote? Horizontal asymptote. And when the horizontal asymptote is at 0, what does that tell you about the function? Okay, the denominator has a higher degree. So we expect the higher degree to be in the denominator. Okay? So right now, maybe I could just like put a 1 there and be like, okay, there you go. That has a vertical asymptote at negative 3, and it has a horizontal asymptote at 0. But then there was another piece of information, that it had an x-intercept at 2. How did we figure out x-intercepts? How did you figure out x-intercepts for your function? Look back. These are the things you have to know. How do we find these? Yeah, Chris. Oh, sorry. Good. So right now, if I set my numerator equal to 0, I would get no x-intercepts because it's impossible for me to find an x value that's going to change 1 since it doesn't have an x. But they're saying I should get 2, which means what should be in the numerator? Not just an x, but an x, what? Minus 2. So that when you set that equal to 0, you would get 2 as the x-intercept. Okay. But now, if I just put this factor in here, does the denominator have a higher degree? No. Now, they told me some stuff about the function, but they didn't say this is all-inclusive, this is everything. They just said, write a possible function that has these things. What do I need to do to my function to make it meet this requirement of having a higher degree in the denominator? Okay, sure. I could go ahead and I could square this. That would work. Okay. I can't just make the x squared because then if I tried to solve for the vertical asymptotes that way, it would look much different. But here, this would still work. So this function would work. You could have also taken it and you could have just put a whole nother factor in the denominator. They didn't say there was a vertical asymptote at 1, but they didn't say there wasn't. And you need a higher degree in the denominator, so you could do that. Okay? So you just have to meet their requirements. That doesn't mean you can't have an additional requirement. It didn't say write a function that has only these asymptotes. All right, so for part B, so write a possible rational function with a hole at x equals negative 1, asymptotes at x equals 4 and y equals 3 over 2, and an x-intercept at 5. So that's a lot of information. Somebody give me something you know that needs to exist in the function based on one piece of information up there. So I'm not asking for the whole answer, just one thing. Matt? Okay. So he's saying one of the factors of the denominator needs to cancel out. Why do you guys think he's saying that? There's a hole, okay? Now, the hole is specifically at x equals negative 1. So what does the factor look like that needs to get canceled out of the denominator? Oops. Yeah, x plus 1. It's getting canceled out. See? Yeah, I'll just say that. For it to get canceled out, then one of those same factors has to exist in the numerator. Okay? So is that okay with everybody why that ended up there? All because I said there was a hole at x equals negative 1. Uh-huh. So Ariana said if it had said the hole was at negative 2, would it say x plus 2? Yes. The numbers here are what you would get by setting the factors equal to 0. All right, somebody give me something else that needs to exist in our function based on another piece of information. Yeah, Jenny? Okay. Should be where? Good. All right, so x minus 4 should be in the denominator because it said there's an asymptote at x equals 4. Now remember, that's a vertical asymptote. Those come from the denominator. And again, that positive 4 is coming from setting something equal to 0, like x minus 4. All right, something else that should be in our function. So the things we haven't addressed are that we have an asymptote at y equals 3 over 2, and that we have an x-intercept at 5. I see Jenny's hand. I'm going to wait for somebody new to... I appreciate it. I just want them all to be thinking. So how are you either going to incorporate the fact that there's an asymptote at y equals 3 over 2 or the x-intercept? Yeah, Caitlin? Good. Okay, and somebody else explain to me why Caitlin chose to put a factor on top of x minus 5. Good. So Matt says because of the x-intercept, right? There needs to be a place that we're going to cross the x-axis at 5. All right, so then the only thing we haven't addressed is the fact that we're also supposed to have an asymptote at y equals 3 over 2. So what's that going to look like? You can put it wherever you want. So I'll tell you guys that Matt asked, can you put stuff in front of the parentheses? I said you can put whatever you want, wherever you want. You're building the function. So can anybody decide how we're going to get a asymptote of y equals 3 over 2? So first of all, if we're getting y equals 3 over 2 as the asymptote, what kind of situation is this? What kind of function? Where's the higher degree? They're equal, okay? Okay, good. So there's got to be, when we set them equal to each other, or when we kind of set up the ratio of the lead coefficients, we need a 3 and a 2 to work out. Now, that doesn't mean you have to put them where I put them. You could have put a 3 in here. But notice that if you multiply out the numerator, you're going to get x squared as your highest degree term. And then by me putting a 3 here, it just guarantees a 3 is going to be in the front of the x squared. Right? And down here, you're going to get a 2, or you're going to get x squared also when you multiply everything out. And putting a 2 here guarantees that you get a 2 as the lead coefficient. Kristen? So the x minus 5 came from the x-intercept at 5. Sorry, the little 5 is way over here. So we just made sure we had something in the numerator to set equal to 0 and get 5. Okay, any questions about writing any of these equations? Yeah, Jenny? Yeah, or you could put, like, it would be all right if you did this also. Well, actually, okay, it's okay to put the 3 in a parentheses, but I can't write 3x plus 1, because if that's not going to be the same as this, right? That's not going to cancel that one out. I could do that. Okay. And then that would still eventually cancel that out, so that would be okay. So the 3 can go into either of these factors. You just got to make sure it's like it gets distributed into either factor. So it might just be easier to write it separate. Any other questions? All right.